Hi and welcome to Gaffy's Grinds. In this video, we are going to do an intro or a quick revision, depends if you've done it with me before, on what is dimensional or unit analysis. This is a very powerful mathematical technique that I teach my students, but I know that some students can still get lost and maybe need to see it again. So when you're doing any type of calculation in chemistry, I think that this technique is useful, but particularly when we're dealing with conversions of moles, concentration, those questions in around the titration calculation in particular, this is very useful for. It's not that well known of a technique, but I find that this is the best way to do any of these types of conversions. Once you get the hang of them, then it's almost difficult to go wrong. Okay. The best example I can pick to look at something like this is the example of a exchange rate for currency. So where I live and my students, we live very close to the border. So my students would typically probably go up the north to do the north of Ireland to do shopping fairly regularly. So a question that you would have when you go up is if I have euros, what are my euros worth? How much sterling am I going to get? How much Great British pounds am I going to get from my euros? Now, of course, most people nowadays, they don't even think about this. They just put it into Google and they can find out, sure. But you it helps if you understand the maths behind what's going on here, particularly when you're going to use those maths in chemistry. All right, so how exactly would we go about figuring this out? Okay, so here is the exchange rate. I just got this from Google today. And what this tells us is that there is €1 for every 88 Great British pence. Or if you like to put those numbers up to 100, we could say it's €100 for every 88 pounds. Okay, so most people would understand that idea. There's a couple of ways we can write this. Okay, we could write it like this, that there are €100 per or for every 88 GBP. GBP, Great British Pounds. So this is a fraction here, which tells us the relationship between euros and pounds. €100 for every or per 88 Great British Pounds. It's also true that there are 88 Great British Pounds for every or per €100. So this is like an interchangeable fraction that you can put either one on top and either one on the bottom. It just tells us the relationship between these. So euros to GBPs. That's very convenient when we go to do calculations. But let me show you how you would use this. Say in this question here, it says convert €147 to pounds sterling. So clearly what we're trying to do in this case, if we plan it out, is we're starting with euros and we're trying to go to Great British pounds. That means the unit I'm starting with, euros, I need to cancel that unit. I don't want that in my answer at the end. I want my answer to be in Great British pounds. So whenever you're doing a calculation like this, you're always going to begin by writing down what you know. We know we have €147. And if you like to think of it, that's just over one because this is when we write a number like this, this is a number that's in a numerator. It's essentially if we divide this by one, it's still the same thing, 147 over one. But we don't really write that divided by one there. We just assume everybody knows that that could be put over one and it wouldn't change €147. And I want to convert the euros to pounds. And I can do this. I'm going to put in the one just so we can track what's going on here. So I'm going to put that over one. And that's just the number one. There's no units on that number one over one. What I'm going to do here is I'm going to times it by a fraction, one of the versions of this up here. Okay. Either euros over pounds or pounds over euros. Because they are both interchangeable, I can use either one of these. That's just the relationship. And either of those is true. So the question is, which version do I need? Well, when we're doing a conversion, we want our units to cancel. Okay. Now, sometimes it can help if we do this all on one line like this. Say we make this all one line. Then what we're doing here is we're multiplying by one of those fractions. So I'm either going to put GBP on top or I'm going to put euros on top. And I'm either going to put GBP on the bottom or I'm going to put euros on the bottom. What I want to do here is I want the units of euros to cancel. And euros will cancel when they're divided by euros. So euros divided by euros cancels them out because anything over itself is just 1. So here we go. We put euros on the bottom so that we can cancel them out. And that means that GBP is going to be on the top. GBP. Okay. Now, obviously, then this is my only unit that's left. And that's what I wanted in my answer because I wanted to end up with GBPs. So the next thing is to write down the numerical relationship. And what we learned over here is that there are 88 Great British pounds for every 100 euros. So now I've got my sum to do. 147 times 88 all over 100. 147 times 88, all that is divided by 100. And that'll give me my answer in GBP. So 147 euro will give me 129.36. And again, I'm always making sure I'm keeping all my units here. My only unit that's left is GBP, Great British Pounds. Okay, so that's how I would figure that out. It should make sense because obviously the number for GBP should be less. If I've got 100 euros, 88 British pounds, that's less than the amount of euros. So I should have less than 147, and that is what I have over here. So logically, that makes sense. Okay, so how can this look different here? Because sometimes when I do this, I'm going to draw it differently. When you get used to this, the way I'm going to show you is I'm going to say 147 euro. I'm not going to put it all over. I'm just going to times by my conversion factor. But really, what you need to know is that's the same as drawing that line the whole way across. But that's not the way I'm typically going to do it when we move on to more complicated ones. I'm just going to say, okay, what do I put on the top? What do I put on the bottom? And again, you're thinking about your units. I want euros to cancel, so I'm going to put euros on the bottom. Now notice I haven't put any numbers on the fraction yet. I always deal with units first. And this is the way I see most people go wrong, is they try and do all these numbers without the units. They just try and be a little bit lazy. For the sake of, what are you going to save? 3 seconds by not writing down the unit? But it's going to mess up your sum. It's going to mess up your thinking process. You're not going to get this right. So that's why it's called dimensional or unit analysis. Look up here, dimensional or unit analysis. This doesn't work without the units, okay? So that's the one thing. If you let this go wrong on you, that's probably what you're going to have done. You're not going to have kept up with writing the units. GBP, 88 over 100, and that's the exact same as above. I want you to know that this here times them by a fraction is exact same as having the line the whole way like that, okay? All right, so again, the best way for us to help you get along with this is for you to get stuck into one now, or for us to get one stuck into one together here. All right, so let's plan this out. What are we going to do? So you should have a copy out in front of it. You're going to need a calculator now, okay? So the first thing I want you to do is plan out what are we doing. So I'm going to ask you now to pause the video and write down what's the units that we're going from and between, from and to, sorry. Okay, so obviously here in the question it says we're starting with 78 euro, so we're going from euro, again, we're going to GBP. Okay, so the first thing I want you to do now underneath this is I want you to pause the video now and write down what we're starting with. Okay, what we're starting with is 78. Is that right? You should be saying, or you should be thinking, no, it's not right because I haven't included the unit. If you don't include the unit, this isn't going to work. 78 euros is what I'm starting with. Now think about getting rid of that euro because we don't want our answer in euros. We want it in GBPs. Now, how can I make that unit cancel? So I'm going to times it by a fraction that has the relationship between euros and GBP. So this is what we call a conversion factor, this fraction here. And then I've got to decide which am I putting on the top, which am I putting on the bottom. And we should be thinking we've got to put euro on the bottom so that euros over euros cancels out. And that leaves us with GBPs on the top, GBPs. Okay, you guys should be able to finish this out now and get an answer, of course, in GBP. Pause the video and figure this out. Oh, if you had forgotten or you couldn't see the relationship, there it is up there. Okay, and of course, then what we should have done here is we should have said that there are 88 GBPs for every 100 euros, or you could have said 0.88 for 1, that's fine too. 78 times 88 divided by 100. And we're getting 68.64 GBP. So that means that 78 euros is equal to 68.64 GBPs. All right, we're now going to do this one together. This one's slightly different because we're starting or we're going a different direction. So pause the video and write down what units are we going from and to. Okay, so hopefully you have caught that this time we're going from GBP to Euro. So we're going GBP and we're going to Euro. So we're going the opposite direction to all our examples so far. And of course, we need our GBPs to stop to cancel out. So what I'm going to ask you to do is pause the video and see if you are able to do this full one by yourself. Okay, so the first thing you should do is write down what we're starting with. We're starting with 400. And again, you have to include the units, guys. It's GBPs, Great British Pounds. And we're timesing it by a conversion factor, which gets us from GBPs to Euro. So again, if you weren't able to get this started, now that I've given you some help, hopefully you can pause the video now at this stage and finish this off. Think about cancelling this out. What do we want to do now? We want to put GBPs on the bottom of this conversion factor so that they can cancel out. And that leaves us with having to put euros on the top here. Of course, the relationship this time is, well, the euros are on the top, so we know that there's 100 euros for 88 GBPs. And our answer, the only unit that's left here, as we can see, conveniently is euros, and that's what we wanted our answer in. So we know we've done it right. This is the great thing about doing this, is you know when you've done it right if you keep the units in. If you don't keep the units in, you won't know. That's the one place where you're going to go wrong, is if you're lazy here and you try and take shortcuts without the units. Then this is pointless, and you're probably never going to learn how to do these conversions. 454.54, and the answer is in euros. Okay, so a reminder, key thing here is you have to keep up with the units. I know it can be a pain to write them down, but that's how you're going to learn how to do this. And this video is for students that I know, my students, who learned this at the beginning, but then got lazy and stopped writing the units and now are a little bit confused about how to convert. This is for those to go back and remind them of the process and basically teach themselves again. Okay, so now I encourage you again, let me be your crutch, but now you got to get rid of the crutch. It's your turn to try these from scratch now. Okay, so no help. I'll put up the answers in a second. You have to be trying to do these problems by yourself. Pause the video and do this now. Okay, and then these are the answers to correct them yourself. Again, if you didn't get any of these right, you're maybe going through this a little bit quick. Go back through it again and try these again. All right, so that is obviously not that relative chemistry, but it's an everyday example and it's an easy one to show you guys. So everyone is familiar with the idea of converting your money to another currency. In chemistry, we essentially want to do very similar things, but we're not talking about money. I'm going to look at an example here between moles and mass, okay? And a relationship that's very important to remember is that for any substance, so this applies for any substance, a conversion for different substances is that 1 mole of any substance is equal to its molar mass in grams, or its molar mass in grams is equal to 1 mole of the substance. So let's jump in and let's try some examples of this. It says here, find the number of moles in 12 grams of neon atoms. All right, so if we were planning this out, what are we going from and what are we going to? It's the same idea as the money. We're going from grams of neon atoms. That's what we're starting with. So we're going from grams of neon, and it's asking us to find a number of moles of neon. So we're going from grams of neon to moles of neon. See the way I plan out all my calculations before? I encourage my students to do the same. Some of them do, and they do well. Some of them don't, and they usually get confused. It's that simple. I'm showing you the way you should do it. If you do it exactly, I think it's going to work for you. If you don't, and you take shortcuts and you're lazy, then it's not going to probably work out, and you're going to struggle with these. It's just the way it is. Okay, so let's write down what we're starting with. 12 grams of neon. 12 grams of neon. Okay, and what did we learn earlier? Well, that 1 mole of any substance is equal to its molar mass in grams. Okay, well, I need grams of neon to cancel here, remember? Grams of neon. So what I need to do is I need to put grams of neon on the bottom of my conversion factor here. Grams of neon. And that means I need moles of neon on the top of my conversion factor. Moles of neon. Okay, so the next thing is, well, how many grams is there if I have 1 mole? So I'm going to let the moles be 1. If I have 1 mole of neon, how many grams would that be? So now you're going to need your periodic table. So I'll let you pause the video and go and find your periodic table. Okay, and the substance is neon. If I go to a periodic table, I'll find the mass of neon is 20. So that tells me that because the molar mass is the MR expressed in grams, and you guys should know how to do that, 20 grams of neon for every 1 mole. So of course, there's my grams of neon here, cancel with my grams of neon here, and that leaves me with moles of neon, which is what it asked me, find a number of moles. So whatever I get here is going to be a certain amount of moles of neon, and I know I'm going to have it right then. All right, so pause in the video and finish this calculation, please, now. Okay, so what you should have got there is 0.6 moles of neon. Okay, well done. If you got that right, let's move on to one where we do it together. All right, so here it says find the number of moles of HCl in 75 grams of HCl. So I'm going to ask you to pause the video and write down, plan it out. What are we doing here? Plan the conversion. Okay, so obviously we're starting with grams of HCl. That's what we know. We have a number here, so we know that. We're going from grams of HCl. And what are we going to? We're going to moles of HCl. That's what we want in our answer. Okay, so let's write down what we know. 75 grams of HCl. Okay, and I'm going to ask you to pause the video, make the grams of HCl cancel, and convert to moles of HCl. Pause the video, do that now. All right, of course, we want those to cancel. How do we do that? Well, we have to multiply by grams of HCl in the denominator right here. It has to be grams of HCl here. Okay, like that. And that means I need moles of HCl on top. Okay, and we're going to take, for 1 mole, how many grams do we have? Well, this time you're going to use your periodic table again and find out what's the molar mass of HCl. All right, so I'm taking the mass of chlorine to be 35.5. That's the number that's in the log tables. I'm taking the mass of hydrogen to be 1. So that's 36.5 grams of HCl for 1 mole. All right, I know I'm right because look at what my unit of my answer is going to be, moles of HCl, which is what I was asked to find, moles of HCl. This is the lovely thing about this. It's got an inbuilt checking mechanism. Okay, so 1 divided by 36.5 gives me 0.027 moles of HCl. Well done if you got that right. All right, let's plan this one out. Pause the video and make a plan here. What are we doing? All right, look at what it asks us to do. Find the mass. So this is our unknown this time. And we've got 7.5 moles of NaOH. So again, if you didn't cop that, pause the video now, plan out the calculation. All right, so obviously what we're doing here, hopefully you've copped this, is we're going for mole of NaOH. That's what we're starting with. And we're going to grams of NaOH, the mass. All right, pause the video and see, can you work out this calculation now? All right, so I am going to do it now, and I'm going to stop again and give you another chance if you got lost or confused along the way. Write down what you know, 7.5 mole of HCl, or of NaOH, sorry, NaOH, and we need those moles to cancel. We don't want them in our answer, we need grams of NaOH. So how do we cancel moles of NaOH? So if you didn't get this far, hopefully now you can pause the video and think about how do we get rid of moles of NaOH. Okay, what you should have done is set up your conversion, and you should have put moles of NaOH on the bottom. What do we put on the top then? That's grams of NaOH. We cancel out the moles of NaOH, they're gone. But we know that for every 1 mole of NaOH, we have a certain amount of grams. So this is our molar mass expressed in grams. Work this out using your periodic table now. Okay, so sodium's 23, oxygen 16, and hydrogen's 1. So that's 40 grams per mole, 40 grams in 1 mole. All right, and then that's equal to, okay, so how are we going to do this calculation and what's our answer going to be in? Go ahead, pause the video and do this if you haven't done it now. Okay, and your answer here should have been 300 grams of NaOH. Well done if you got that right. Okay, so some for you to practice now. Pause the video and do these. Remember, it's really important that you do the independent practice. Otherwise, you're not letting go of me as the crutch, and you're always going to need to watch me and look to see what I'm doing. You have to be able to take control. Come on, let's make sure you do it now. Okay, so here are the answers. Or are they? Did I do these? Oh, didn't actually do the answers for these. So I will do them quickly now. Apologies. So 6 moles times by HBr. All right, so this one should have been the first one should have been 486 grams of HBr. Well done if you got that right. The second one will be the second one will be 2.4875 moles of MgO. Well done if you got that right. And then the last one 0.05 grams of NaOH. Okay, so hopefully you got those all right. You are now ready to move on to the second video where we take this idea of unit analysis, now that we know that what unit or dimensional analysis is, and we look at a lot more of the specific types of conversions we need to do a titration calculation. And then once you're happy with those, you're ready to move on to looking at the ordinary level titration questions first, and then we'll move into the higher level titrations questions. So this series is all about building you up to be confident on the hardest types of calculations. For some of you, you may never go to the higher level because you may end up doing the ordinary level, but you still need to be able to do the calculations. So this is still a build up. So you can go to the end of the ordinary level questions, and then you can stop if you're not going to be doing the higher level. All right, so I hope this is helpful to my students and especially to anybody who's new to the channel and maybe you're confused about the way your teacher's shown you and you're not sure what to do. Maybe this will shed some light and make it slightly easier. I'm not going to lie and say that loads of students find these questions easy. I don't think that they do find them easy. I'm trying to show you especially when you get to the higher level questions, there's a very much a logical way of thinking your way through, and a lot of students get lost in there. But if you can always keep the units in mind and make sure you keep track of what you're doing in terms of units, then it really helps you plan out your pathway. Rather than trying to rely on stupid formulas or tables or grids, and you're just plugging numbers in and you don't really know what you're doing and you're hoping you're guessing you're getting the right answer. This should be a more logical way of thinking your way through. It's also better for your general math skills that you're able to do this type of conversion. You're able to analyze the units in this way. All right, so I hope you found this video useful. I shall see you in the next one.